Now I'm going to demonstrate what happens if the rewinding is done incorrectly and the operator forgets to select the slip setting for the clutch. Very important that the slip setting is selected for every rewind to allow the right amount of tension to be applied for the rewinding. You need to get the wind on here really tight, and the way that's done is the clutch gives us tension on the line as it's being pulled onto the rewinder. So it should always be in the slip setting. But what could happen is you could forget to have the setting on slip, so it's on, the clutch is off, so the spool is free to rotate like this. The rewinder will still pull the line off, but it won't have that tension. So we'll do a rewind like this so we can see what it looks like when it is done incorrectly. You can see here there's quite a lot of movement in the line. On the tail spool it doesn't look very much different to a proper rewind, so maybe you might not notice, but this is a good indication here that there's not enough tension on the line because it's moving around a lot as it's coming off the spool. But when the probe is dropped, there will be a problem because the line will not pay out correctly from the tail spool as the probe is dropping. So I'll continue rewinding to put a few layers more onto the probe so we can see what it looks like. So maybe at this point you've realised that the clutch is off and you think, well, okay, well maybe I'll just continue and do the drop anyway, but we definitely would not recommend that. We recommend the line being taken off the tail spool before it's used. I'm going to load about 350 metres on, which would be somewhat of a normal amount of line that will be loaded. At 310, so I'll stop it when it gets to the top here. You can see pretty good indication something was wrong here. This is all pulled off with the momentum of the spool. So what we see here is a really soft wind where you can move the line around. You can see it's all crushed in together, or the layers aren't discrete. And if this is used, you will get a very erratic drop rate, and also the line may come off in clumps, so you may get knots in the line which could cause breakage and you could lose the probe. So if a wind looks like this, don't deploy the probe. This is an indication of a very soft wind. So the softest wind you can achieve is with no tension, but it's something to watch out for when you're using the system. If you see any of this sort of characteristic here where the wind isn't really very tight, then it's worth looking at the winch and adjusting the tension to make sure you keep within the specifications and have a good tight wind. And I'll explain how to do that later.